YAML. sklearntreeplottree. Description. The plottree function from scikit-learn's tree module is used to visualize decision trees. It provides a graphical representation of the decision tree structure, including nodes, branches, and leaf nodes. This visualization helps understand how the tree makes predictions based on the input features. Inputs. Decision tree. A fitted decision tree model created using decision tree classifier or decision tree regressor. Feature names. An optional list of feature names strings corresponding to the input features used to train the decision tree. This helps label the nodes and branches with meaningful feature names. If not provided, default numerical indices will be used. Class names. An optional list of class names strings for classification trees. This labels the leaf nodes with the predicted class labels. Filled. A Boolean value indicating whether to color the nodes of the tree. If set to true, the nodes will be filled with different colors based on the class or value they represent. Rounded. A Boolean value indicating whether to round the corners of the nodes. Precision. An integer specifying the number of decimal places to display for numerical values. Ax. An optional matplotlib axis object where the tree will be plotted. If not provided, a new figure and axis will be created. Font size. A floating point number specifying the font size for the text in the tree. Impurity. A Boolean value indicating whether to display the impurity Gini impurity or entropy at each node. Node-IDs. A Boolean value indicating whether to display the node IDs. Proportion. A Boolean value indicating whether to display the proportion of samples that reach each node. Rotate. A Boolean value indicating whether to rotate the tree. Feature names. An optional list of feature names strings corresponding to the input features used to train the decision tree. If not provided, default numerical indices will be used. Class names. An optional list of class names strings for classification trees. This labels the leaf nodes with the predicted class labels. Outputs. Visualization. A graphical representation of the decision tree, displayed using matplotlib. Axis object. The matplotlib axis object containing the plotted tree. Steps. Initialization. The plottree function takes the fitted decision tree model as input and initializes the visualization process. Node placement. The function determines the placement of the nodes in the visualization based on the tree's structure. Branch drawing. Branches are drawn connecting the nodes, representing the decision paths in the tree. Node labeling. Nodes are labeled with information such as the feature used for splitting, the threshold value, the impurity measure, and the predicted class or value. Visualization display. The final visualization is displayed using matplotlib. Metrics. Gini impurity. The Gini impurity measures the probability of misclassifying a randomly chosen sample from a node. Entropy. Entropy is another measure of impurity, calculated based on the information gained from a split. Visualization plots. Decision tree visualization. A graphical representation of the decision tree, showing the nodes, branches, and leaf nodes with labels. Fine-tune parameters. Filled controls whether the nodes are filled with color. Rounded determines whether the node corners are rounded. Precision specifies the decimal places for numerical values. Font size controls the font size for text. Impurity determines whether to display the impurity measure at each node. Node-IDs shows or hides the node IDs. Proportion controls the display of the sample proportion at each node. Rotate rotates the tree for better visualization. Feature names labels nodes and branches with feature names. Class names labels leaf nodes with class names. Uncertainty methods. Not applicable. Challenges and fixes. Challenge 1. Overfitting when the tree is too complex. It can perfectly fit the training data but fail to generalize to unseen data. Sample use case that resulted in challenge 1. A decision tree trained with a high max depth value might overfit the training data. Fixes to challenge 1. Pruning using methods like max depth, min-samples split, and min-samples leaf to limit the tree's growth and prevent overfitting. Regularization employing techniques like CCP alpha to penalize complex trees. Challenge 2. Unbalanced data. If the dataset has an imbalanced class distribution, the tree might favor the majority class, leading to poor performance on the minority class. Sample use case that resulted in challenge 2. A classification tree trained on a dataset with 90 positive samples and 10 negative samples might primarily predict the positive class. Fixes to challenge 2. Class weights. Assigning weights to different classes to balance their impact on the trees. Training. Sampling techniques using techniques like oversampling the minority class or undersampling the majority class to balance the dataset. Cost-sensitive learning. Adjusting the cost of misclassification for different classes to prioritize accurate prediction on the minority class.